Hi guys, Mr. Johnny here. In this video I will try to shortly glance across the topic of changing power rating of the CFL. Because one of you, Josip or Josip, I really don't know how to pronounce your name right. Sorry about that. Anyhow, I want just to show you a couple of experiments I've done today, and I found out what really works to change the power consumption. Because in a previous, it was a comment to my video where I mentioned that I changed the power rating of the ballast by changing one capacitor in it. Now be aware that some of the ballasts, like this one, has two capacitors like this. Reasonably, where are they? Oh, this one has this has one. Damn, where was it? Where was one with two? Here, you dummy. This focus, not zoom. See, there is one capacitor 47 nanofarads 400 volts, and there is another one. They are connected in series between themselves, and then ends go to negative and to positive of the rectifying mains forms the other half of the bridge. Changing those values, if you have two capacitors, won't change much. Because I tested that before, pretty much in the same time frame as I did that modification, as I did that ancient modification to that currency detector from 2015. Another ballast, as you can see on this one, has only one capacitor. This one has to do something else with the starting circuitry and rubbish like that. We're not in... Yeah, it's a starting cap. We're not interested in this one. See, there's only one reasonably large capacitor. This one is 47 nanofarads as well, 400 volt rated. Maybe you'll be able to see it. Oh well. So, if you have only one, it works pretty good, but not nearly as good as changing the choke, which I did here. So the guts you see on the table came from this CFL, which is rated 15 watts, as you can see, right? And this is original choke. The choke on the table, using with this lovely tape, which Big Clive would definitely approve. This one has an inductance of about 2.8 millihenries. So, without further ado, let's plug it in. Hope it doesn't go bang, because it might. And let's take let's take a measurement of how much current it draws. Times 10 range, so kaboom. It didn't go kaboom, that's nice. So just move decimal point one place to the left, so you have 15 something watts. Alright, you see it, and it climbs up as the actual tube warms up. You see the rating is about 15, 16, something like that, close to 15 watts. Fine by me. So, next experiment is that I'm gonna go and put this choke in, which I yanked from this ballast, which I showed you already. This one, funny thing is that this one came from 20 watt CFL, and the value of this choke is 4 millihenries. It even says you so. See, L 4.0. I measured it, it's like 4.3 millihenries, so it is larger inductance than the one you see on a table right there. But because these things are quite unpredictable beasts, having larger inductance does not necessarily mean you will have less power. Because this one was definitely 20 watt. Alright, so now I'm gonna go and just solder it in place of this. It is unplugged, of course. I'm not that kind of moron. me just stick it in place. Alright, that should do. Now it should definitely go bang. So through 4.3 4 millihenries instead of 3 millihenries. We're having 12 watts now. Let's give it some time to warm up. Previously, when it warmed up, it climbed close to 16 watts. Now it climbs close to 13 watts. Alright, better yet. Next, why don't we go and connect these two chokes in series? You can see 12.5 watts. Alright, connect these two chokes in series. So 4 millihenries, 3 millihenries should be roughly 7 millihenries. These are quite rough values because this choke actually measured 4.3 millihenries, this one measured 2.8 millihenries, but to hell with it. This is supposed to be a quick video of me blowing up my CFL, so you don't have to blow yours. Alright, twin series. Camera is focused. Kaboom! It didn't go kaboom, but the golden word here is yet. So I should not be very close to it. Let me get something to point with. Anyway. You can see 9 watts now. Can you see? About 9 watts. So now we consume only 9 watts. With the stock choke, this bastard, with a lovely shade of pink. The one with the tape, which is like a lovely shade of pink. But anyway, Kino Babel, stop. Alright, I'm gonna pause. Alright, I gathered my thoughts. As you can see, with two chokes in series we have about 8.6 watts instead of almost 16 watts. So let's say 9 and 16, so we dropped 7 watts, is it? 16 and 9, yeah, 7 watts. We dropped 7 watts, which is not bad. From the original rating, which is 16, so that's we almost smacked it in half. That's a almost 44% decrease. So if you're watching, just go and connect some chokes in series. Maybe you'll get close enough to the necessary value. I would not really recommend. Unplug it and sense how the transistors feel. They're pretty much cold. Oh yeah, they're much colder than they were. But there might be a case I didn't say to zoom in, god damn it. Alright, we have to live with this focus because the screen that I purchased, because that's my phone, not my mom's phone that I'm filming with right now. The screen is what I purchased is actually a cheap replacement, and it has quite a rubbish quality touch screen, so sometimes it misbehaves. Alright, so, but sometimes when you decrease the power, you might need to go and change some turns on this transformer. Normally I won't recommend you to touch this transformer if it works right, like in my case. The transistors are not very hot, everything is hunky-dory. But if you might, let's say, take a 20 watt ballast and turn it into a 4 watt ballast, you might want to actually go and modify this winding, which you can see a large winding in comparison to two others. Oh, there we go, now it focuses. this green winding, which is connected in series with the load. If you will trace the circuit, I won't do that here to save time, because it's already over 10 minutes long. So it's a current transformer. If you decrease the load very much, the current flowing here will be lower because it's equal to the load current, and so will be current through the bases, and you don't really want that. Because if the base current on these transistors is gonna drop below certain value, they won't turn on as hard as they should, and they will act as a resistors instead of a switch. They will dissipate a lot of power and may burn out. I had one which did just that, so be careful. If you feel that these things heat up a lot, go and decrease the number of turns here. Let's say just take a turn or two out and check again. You will need to find a beautiful spot. So that's that. I'm gonna wrap it up here before I made this video into a 20-minute long babble. Thanks for watching. See ya.